All right, friends, let's look at how this for loop unfolds. So I apologize. I made two mistakes here. One is I forgot to pass in the current offset. And then the other one is the partial would be appending the what is stored at the current offset, right? So this won't be, let me go ahead and actually, I am doing too many scratches. So let me borrow the eraser. Uh, from from here and try to erase this part. Um, so let's see, I can erase that out. Probably just cutting that off would have been easier, faster, I believe. All right, so that's out of our way. So, but the nice thing about the about working these things out is that even if you make a mistake in your understanding of or writing the for loop, you can when you can evaluate when you're evaluating the branches, you can see what's the mistake, right? So the mistake I made was say we call our recursive function perm with input s and subset size k. Now appending partial is appending what is stored at the current offset, right? So current offset, and then we need to increment the offset size or the current offset plus 1, and pass in the result, right, where we are going to store the result. So to begin with, let's say the current the starting offset was 0, right? So what it did was it said, okay, swap the offset 0 with 0. So 0 swap with 0, a swap with a, nothing happens. We appended a here to which is the current offset, and then we incremented the offset by 1. Then we went to b, current offset b swap with b, nothing happens because remember this is the swap step. So this is the first, and then we do the attaching to the partial, and then third is restoring the swap, right? So um, so now we have collected. So our current offset is 1, right? And we got into the partial b, and then our current then we incremented the offset, and we got to offset 2, 0, 1, 2, and then I added that to the partial, so a b c, and then the base condition would probably kick in here and say, okay, now I have partial is equal to the size, then I'm going to store the partial. So ABC will be stored. So now, and it returns. So remember our current offset was 2, 0, 1, 2. And then the swap executes again, and then it's going to swap 2 with 2, which would be swapping C with C, and nothing happens, right, for the first. And then I increment. And remember the size of this is 3. So when I becomes 3, then this will exit. So for the last offset, this will execute, the for loop will execute just once for the C, right? So now it returns to the offset 1, right? So now the recursion comes back to offset 1, when we are at this particular point, right? So it is done with that branch, and now it is executing offset 1, right? So when we started with the offset 1, we had added b to that, right? And we said that, okay, we uh, we had done with the I equals to current offset loop, and we had collected, and the swap thing again kicks in, and it swaps B with B again, which is kind of waste, but the heuristics works well. So the first swaps offset with the I doesn't do anything because I is equal to offset, right? So then it does the swap again, but then I increments, right, for this offset 1. So then the I increments to the next offset, and the swap would happen between the current offset, which is this offset 1 here, and the I will be 2. So I will be 2. So what happens when you swap these two is C, and so C comes to B's position, and goes to C's position, right? So this is what you get. So C and B are swapped, and then what we are saying is, okay, after you're swapping, to the partial, add the element at the swap position, right? So add the element at the offset position, which is what this guy is doing. So we had A, and then we are adding C to that, and then we say okay, and then I'm going to increment the offset. So and the same thing. So then I get A and C, and then I incremented the offset. So now the offset is 2. And remember, at the offset 2 position, now the element is B, right? So that is element B. So and at the for the last offset, it's just execute once because then I becomes more than the size, right? So then we collect B out of that, and we add that to our partial. So now we have ACB, and then we are done with this particular branch, right? So for this particular offset, we would have done the second iteration as well. The third iteration would probably would increase the size, right? So then this branch returns back, right? So it returns back, and now we return back to the offset, the iteration for the offset 0, right? So we were doing, so for the offset 0, we had added that, and then we called our recursion, and then the recursion added this, and then for this we did this swap, and we collected, and then we returned back here, right? Now for zeroth offset, swapping 0 with 0 is not going to do anything, because that is the when we return the swapping of offset of I, because I is 0 and offset is 0. So then I increment, right? So I is incremented, then A and B will be swapped, right? So now A and B are swapped. If you see here, so I have A and B swapped here, and then we collect what is there at the current offset. So current offset is, remember, is 0, right? And at this offset now it is B. So B gets added to partial, and then we do the same thing, and we say that okay, go ahead and increment the offset, and so now the original string. So remember that we are modifying this original string every time we proceed through this. So now for this particular iteration, the original string that we are iterating is BAC, right? Because we have swapped A and B's position, and we have collected this, and then we have passed in A and C down here, and then for this particular offset, we also do the same thing. First, we collect what is there at that offset. So we collected that BA, and then the last offset C, and that returns, and then we swap A and C, same thing. So then A and C is swapped, and that becomes CA, and that gets added, and we come here, right? And then we return back. So we are done for this particular offset uh, for A, right? So now we go back to, and then remember at the end of the iteration, we swap and restore the position every time, right? So then we go back to this original string A, B, and C. So now we are evaluating for offset 0, and we are currently our I is at the third iteration, so I is equals to 2, and it is going to swap what is there at 0th offset with what is there at I equals to 2, right? Remember this swap operation. So uh, so ABC, so A and C will be swapped. So this would be the position. So CBA, so it will become CBA here, and we have collected C here, and then the this could be better written as CBA to represent this swap, right? So now I have C, I have collected C, which was at position, which was at offset 0, and I'm passing in these two, this modified string here, and the same thing happens here. So the same thing happens here. I do not, so the offsets at this position is 1. So the current offset is 1, and B with B swap would do nothing. So we collect B. So that would be C B A, and then we do the same thing, swapping B and A to A B, and that would give us one more unique subset. So it's a little bit hazy, or I would say hairy, to grasp at the first. But if you pay close attention, it's nothing but swapping of the offset, of the current offset at every iteration, right? With the current incremented so-called for loop variable, right? So which is what this guy is doing. If you look at this, so uh, once we program this, probably it will become more clearer. So let's take a look at how the software is going to function once we